Yeah. So welcome to today's class. Today we'll be talking about pointers, and then after pointers, we're going to talk about arrays, right? So I'm going to open my diagram again. Remember, we had a diagram. I think I still have it stored. So I'm going to open that diagram because we talked about variables in the previous session, right? So from variables, yeah, there it is. So from variables, I'll just go straight to come on. I'll just go straight to pointers, right?
Okay.
So how do we store how do we store what's the whole point? No pun intended, but what's the whole point of pointers, right? Like what's the whole point behind it? Okay, someone's joining. Just make sure you guys mute. Okay, I don't hear any background noise, so I'm assuming it's muted. So what's the whole point of pointers? So pointers, right, especially when you start doing second semester, right, you'll be talking about something that is called OOP. So basically it's a way or to represent objects in a computer. So for example, a chair, a microwave, a desk, those are objects, right? So they tend to be very big, and it's better to instead copy the object itself, but just taking the addresses of where the objects are stored because they tend to be very big, and we want to make our application fast. So pointers, they tend to be useful in those type of scenarios, right? When you want to make use of its address, where the variable is located, where it's stored, that's when it becomes very useful. So how do we? There's two. Come on. There's two ways to work with addresses to keep track or to work with addresses for each variable. There's what we call I think it's called type aliases, right? Then we have pointers. So we have those two, type alias and pointers. So I'm going to open code blocks. I should open the wrong thing again. Then I'm going to click here. So there's something that we call type alias and pointers, right? There's those two types, a type alias and a pointer. So those are very useful when you are working with when you want to keep track of the addresses. So when you want to keep track of the addresses, you either use pointers or type aliases. So what is a type alias? So basically, it's like you give a different name for the same variable, right? A different name. But then that different name, they point to the same box, right? Basically, it's going to take the address of where that box is stored. So that's what I call a type alias. So it's like we are naming the box in a different way, but it's still the same box. We're still pointing to the same box. So for example, if there's two of you and you guys are pointing to a car, both of you are pointing to the same object or the same thing, which is a car, right? You just happen to have different names, but it's the same. You're referring to the same thing. So that's what a type alias is. So it's a way for us to give the variable a new name in a way. You can picture it in that way. It's like giving a variable a new name. So this one is about pointers and arrays, right? Because why am I talking about arrays with pointers? Because pointers and arrays, they're linked, right? They're similar. Arrays use pointers under the hood. So that's why I'm doing what I'm doing. That's why I'm teaching it in this order. So we talked about variables, right? Let's just a quick refresh on variables. Remember, I talked about variables that when you create, for example, an int num, by default, you can imagine there's an invisible sign here, meaning that this variable can take in both negative and positive values. And then if you want it to take only positive values, you say it's unsigned, meaning it doesn't have a sign, meaning it's only positive numbers. We talked about that quite extensively, so we're not going to get into that too much. But from now on, I'll just here and there use the keywords so that you guys become more familiar with it. So let's say we have int value, right? Let's call it int value 1 because here it's called value 1, right? So the name of the variable will actually become the label on my box. Then the data type, it describes what type of things can you put in the box. In this case, we are telling C++ that we can only put numbers, and not just any numbers, specifically integers. If you remember in high school, integers, we say that is an element of Z, meaning they belong to the set of Z, which is integers, right? So that's the same thing we're talking about. Those are the same integers we're talking about. But in this case, I use a double. It doesn't matter. You can still use an int. Doesn't really matter. So this is the variable, right? If you want to apply something that we call a type alias, there's something called a type alias, right? So type alias. Alias, it just means another name for the same, basically giving the variable a different name. Why would you want to do that? Because instead of you creating a whole new variable, remember every time you create a variable, C++ or the computer, it creates memory that's big enough to store the information for that variable. So if you have an int, it's going to make a box that's big enough to store the integers. So we don't want to waste memory, so we can use something that we call a type alias. So instead of creating a whole different type, a whole different variable, we just create a different name for the same box, for the same variable. We just use a different name. So for example, if I say int value 1 and then I initialize it to 0, like I said, I'm gonna use this approach. For me, I like that. You choose what you wanna use. So I'm gonna say int value and then initialize it to 0, right? Then I'm gonna create a type, what do you call a type alias. Let me see if I still remember. Let me think. Type alias. Yeah, I think if I'm not mistaken, the thing is that I haven't done type aliases extensively. I know pointers, most of it. Let me see. Let me say val ampersand val is equals to value 1. Will this work or it won't work? Yeah, it works. Let me just, does it work or what? Yeah, seems like it. Let me build and run. Yeah. So I still remember the syntax. So this is what we call a type alias, right? So what does this mean? It means that go to this box with this label value 1, right? It's gonna go, C++ is gonna go into the computer. It finds that box. It's called value 1. What I am telling it, right, is that it should rename it to val. By renaming it, it needs to go to the address of that box and give it a different name and call it val. So I can basically, it's like you have two names that refer to the same box. So you can either call it val1 or val. So now you can imagine this box has two labels now. That's what code type alias is. So you might not understand what's the significance for that, what's the importance for that. The reason why that is important is because every time you create a new variable, it allocates memory for it. By memory, if you look at your files inside your file explorer, right? This is what you call this is what you mean by memory. All those bytes and bits we're talking about, right? They add up to what we call kilobytes, megabytes, gigabytes. You see, there's the KB, kilobytes. So we want to make sure that that number is as small as possible. So we tell C++ not to create a whole new variable, but to give that box a different another name, not necessarily a different name, but another name. So that means these two names refer to the same box, right? So in this case, let me put an actual value. Let me say this box stores the number 42, right? So that means this box, inside of this box, there's the number 42. So I'm going to demonstrate that. So here, there's 42, right? So this means this 42 is inside this box, right? Yeah, just know this 42 goes inside the box. So that means when I tell C++ output the output, what's inside the box with the label value 1, it's going to show me 42 because that's what's inside the box. So even if I say val a different name, it'll still output 42 because this box actually has 2 labels. So you can refer it in one of 2 ways. Then now I'm going to output it. I'm going to say cout value 1, right, and line. Then I'm going to cout val. But then at the end of the day, they actually point or they refer to the same box. So I expect the output to be the same. So let's run it. And you see, I wasn't lying. Is 42 and 42. So they refer to the same box because I use what we call type alias. Alias meaning another name. So we gave that box another name. This is the syntax. This is always the syntax. You always put this ampersand or this and sign followed by the new name you want to give the box. This will become very useful when you see, I'm sure now you can understand. You still remember about pass by reference when you're doing pass by reference. We're actually using what we call type aliases. That's what we're using. So that means that we're not using any memory at all. We are just referring to the same box but with a different name. So that means it wasn't actually creating new variables. That's why when you do this, let me show you. That's why if I was to say val, right, and I say is equals to 33, it'll also affect value 1 because they're both referring to the same box. So to prove to you that what I'm talking about is right, I'm going to change it before displaying. So now my output should be both 33. You'll notice that I didn't change value 1, but the output is 33 for both. Why is that? Because they refer to the same box. So you change one, you also change the other one. So you need to really understand this. This is very important when it comes to functions. When you start talking about functions. Then we have pointers. So with pointers, it's similar to this, right? You see, it's similar to this, but there's quite a lot to understand. I did send you a recording on that. You can also rewatch that one if you wanna understand more, but I'll try to explain it again. So we have what we call pointers, right? So pointers, remember this variable val, it doesn't store any address. It still stores the values. You see, that's why I'm able to say val is equal to 33. Because it doesn't store an address. It stores only the value. We just gave the same box a different name. So it's still a variable. It's still a variable, still normal. But what if I want to store both the value, which is basically what is inside the box? So what if I want to store 42 and the address of where that box is? What if I want to store both? That's where you do what we call a pointer. You use a pointer for that. So here, let me just give this a color. So you use a pointer. If you want to store both the address, where that person is located, and what is inside that box. So this is how you declare a pointer. You say int, right? It's up to you. There's 2 ways. You can put the star or the asterisk after the data type and then space, then you give it a name. For example, I'm going to call it num, right? Or you can put the star right before the variable name like this. These are the 2 ways. You can do it this way, or you can put the star right after the data type. That's up to you. Me, I like to do it this way. Then you're gonna try to initialize it to some address. Because remember what I said, this is a pointer. It stores an address. Why do they call it a pointer? Well, the variable itself, it stores an address. Then this pointer points or goes to this address. Hence, it's called a pointer. So when you have num on its own, when you output num, when you say cout num, this is going to store the address. Then when you put a star right before the variable, you're basically telling C++ to point to that address. Basically go to that address. Obviously, if you go to that address, you'll find the thing that's stored in the address, right? So in other words, this gives you back the value. If you want to get the address, you only simply output the variable name. If you want to get the value at that address, you point to that address. Then you get the value or what is stored inside the variable, inside the box, or inside the box, not the variable, say inside the box. So there's two ways you can initialize. Okay, there's three. There's three ways you can initialize a pointer. When you initialize a pointer, right, you need to give it an initial address, or it needs to point to something or refer to some address. To get an address of a variable, remember we talked about it. To get an address of a variable, you put in the variable itself like this, right? That's the variable. Then you use the end sign, ampersand. I want you to not get confused. Look at where, in which side the end sign is, the ampersand is on. If it's on the left-hand side, then we're talking about type aliases. If it's on the right-hand side, then I'm telling C++ to get the address of that variable. There's a huge difference. This creates a new name or a different name for the same box. This gets the address of the box. Two different things. Look at where they're at in terms of when you look at the equal sign or the assignment operator. This one is before the assignment operator. This end is after the assignment operator. So this will be the first way you can initialize it. So what happens? What is going on in this line of this one? This is what's going on. So you are telling C++ to create a new box with the label num. So it's going to do this. C++ is going to come here and do this and say num, right? And then this variable, it stores an address, right? So I'm going to do this. So I'm going to say this is an address. So int star, int pointer, right? This is a pointer. Basically, when you say int star, you are telling C++ that this variable points to an integer. So C++ is going to expect you, since you said int pointer right here, you're telling C++ that this variable points to an integer. So therefore, it expects you to get an address of an integer, not a string, not a char. If you try to do that, error. Because you told C++ that this variable stores, this pointer stores the address to an integer. Basically, it's going to point to a number, which is an integer. Then now what C++ does, then it executes the right-hand side and value 1. So the end value 1, it means that get the address of value 1. So it's going to go here. So the value that's going to be inside the box is going to be this address. The address of where the box with the label value 1 is stored. Then this box will only store an address. So that's why we call them pointers, because they point to variables or they store addresses. They don't store values. So you see, there's a difference. This one stores a number, this box. This box stores an address. But then this address should point to a box that stores a number or an int, because we said int star here. Don't forget that. That's very important to understand, or else you're going to get errors. I think I should also share this diagram once I'm done after today's class. So there's the variable. So the variable, so basically in a way, right, this is what it means. I know the diagram might not be as clear, but this is actually what it means under the hood. You're telling C++ to basically do this. The box with the label num, right, it's going to say num is equals to this. So num, when you call num on its own, right, it means that it has this address. But what if you want to point or go to that address? You have to say star num, which just basically means go to num, meaning go to this address. That's what it means when you put that star right before the variable. So that means it's gonna go to that box with a specific address, then get the value. So if you want to output the value, you do this. If you want to output the address, you output num on its own. So this would basically, there's the address, then it's gonna look for all the drawers, all the shelves with that address. It looks, and then it finds it. There it is. Then it goes inside the box, it gets the value 42. So In this case, it's 33, right? It's fine. It's 33. So let's output the values, right? So I'm going to say, I'm going to output pointers, output a \n, so that you know the difference. So this output was for type aliases, right? So type aliases, so that when I send you this code, you can see the flow. Then here I'm going to output the address. So I'm going to say cout to output the address of the variable, right? So how do I do that? Remember what I told you. You use the variable without the star. That's because the variable itself stores the address. Then now if you want to get the value at that specific address, you have to point to that address or go to that address. So I'm going to say cout, and then value at that address is going to be num. But if I just write num, it's going to output an address again. So I have to point to or go to that address. So I'm going to put the star to point to this address. So that means I'm going to that address. It's like you visiting Chomi. So this is you going to Chomi's address. So obviously you expect to find Chomi, right? The same thing applies here. You go to a box that stores an integer. You expect to find an integer. So this will output the integer over here. Then I'll build and run. So the answer should be 33 because remember we changed it there. So you see, there's the address. There's the value 33 because it points or it's linked to this variable over here. So that's why it's going to be the same value. And to prove to you that they link to the same variable, right? I'm going to change my pointer, right? So I'm going to say, remember, you can't use the variable like this. This refers to the address. If you want to change the value, you have to point to that address. Then you say is equals to 123, right? But then look at something very interesting. I will only output value 1. But for some weird reason, value 1 is now changed. So I'm going to say value 1, then value 1, then ENDL. But then for some weird reason, you see that value 1 has changed. Why has it changed? Because they point to the same box. They refer to the same box. This pointer has an address of that box. So if I change this, I'm in essence changing that box. So that's why the answer will be, that's why the answer, the new value will affect value 1 too. So you see now value 1 is 123, but I didn't change value 1. Well, you didn't change it directly, you change it indirectly. Remember remember the pointers, right? When you put this asterisk here, you mean point to or go to that address. So that means it's literally going to that box. So this line of code over here, this is what it's going to do. It's going to look at whatever answer stored, whatever value stored inside num, then it points to that num or that address. So there's the address. It's going to start there, look, it looks, and then it says, oh, there it is, I found it. Then inside the box, that's when we look at the assignment operator. Then I'm telling it to go inside that box once you've found it, go inside of it, put the value 123. That's literally what I wrote there. So it found the box. This is the box over here. This is the box. Then it goes inside the box, it changes it to 123. So that's why when I displayed value 1, it showed 123 because I actually changed the box. I changed what's inside the box. That's the power of pointers. So you need to be very careful with pointers because you see that you can change variables that you don't intend to change. The variables you're not planning to change. So you should be very careful and change only the variables that you really are planning to change. So yeah, so this is basically pointers. And then I didn't show you the other way. The other way to initialize it, right? There's this thing called null pointer. You can say it's equals to null pointer, which basically means that it points to nothing. That's basically what it means. So if you try to do this over here, it's gonna crash because it points to nothing. It needs to point to some box in order for you to be able to put in a value. So if I try to build this, you see that it should crash. Yeah, C++ does that. It won't crash, but it will just jam. You see, it just jammed. That's the problem in C++. It won't tell you where the problem is. You have to use common sense. So now pointer, you should try to limit it. Try not to over abuse it, right? Just initialize it to the address of a variable. That's simpler. You are bound to make less mistakes doing that. Or there's a different way, but that different way would I have to explain stack and heap. I'll explain those in second semester. Let's not touch that because that's gonna require a lot of time for me to explain. Let's not touch on that. They're very important in second semester, not now. But I could teach you now because you need to know all the different ways. So let me. Can you please mute whoever's unmuted? So I'm gonna save this diagram. Then I'm gonna talk about arrays now. Then class. I'll end the session. So I'm gonna save it as a PNG, save it under downloads, and then save. So yeah, I've saved it. So can you please mute? I don't know why you keep unmuting. Because if you leave your mic open, you're disturbing my train of thought. Now I can't think straight because now I'm hearing background noise. So this is the variables, right? So arrays work in a very similar manner. They're very similar. To be honest, arrays and pointers exactly the same thing. The only difference is that now you have multiple pointers. Instead of one pointer, you have multiple pointers. In a way, right? You have multiple pointers. So let's make the example of a array, right? So I'm gonna delete this, and then I'm gonna add. Yeah, let me add this. So this is how an array looks, right? Under the hood, the arrays look like this. So copy, paste, then paste, and then I think, yeah, just three. An array of size 3 should be enough. It should be sufficient to explain what I'm about to explain right now. Then, as always, as usual, right? We always have a box, right? At that specific location or a variable. Basically, an array. Another ways to understand an array. We have it's storing multiple variables under one name. Then you can refer to one variable at a time by putting the position or the index. We call that the index. So each of these boxes or these multiple variables, they have positions. They don't have names, so don't worry about the names. The only thing that they have is the data type, which is the data type of the array, right? So that means if you have an array of integers, all of them are ints, right? So this would be, let me quickly zoom into this. Then quickly change this color. Color, let me make it blue, apply. So we have this over here, and then we have this. So if you said you want to create an array of integers, what that means is that every single box, you cannot mix the boxes. There is a different way to mix them, but we're not there yet. If you have multiple boxes like this, right, they have to be of the same type. They must store the same thing, which makes sense in a way because if you get for example, let's say you go to Pick n Pay and you want to buy cooking oil, you can think of it as like there's a lot of cooking oils. If that English even makes any sense, but you can imagine there's multiple oils, right? Because if you take let's say you take a drop of oil and then take another drop. So you can have multiple drops that end up filling up a 2 liter or 1 liter. So like I said, you can view it as like multiple drops of oil, and that's why um and if you've noticed when you buy the oil, again, you only find the oil in that one container. You don't find maybe half is oil, the bottom half is oil, and then the upper half is stay soft. Have you ever bought something like that? No, because you shouldn't mix things. So when you create an array, it means it stores at each position the same type of information. You can't have all of a sudden you have an int here, then you have a double here. No, it's going to crash. That's impossible. So be sure you understand arrays. Then each of these boxes, they are stored at the location where it's stored. Yeah, we call that the index, right? So it'll be at index 1. Since we start counting from 1, computers, they do the opposite. They start counting from 0, right? They start counting from 0. So 0, and then this is position 1, and then position 2. For us, we would say this is position 1, position 2, position 3. Basically, think of it as like a queue. Yeah, the queue there at Capitec month end. You want to withdraw money, and there's a long queue. Yeah, let's say there's the first person, that'll be number 1, right? Person number 1. The second person will be person number 2. The third person will be person number 3, right? And so forth and so forth. So you can picture it in sort of like in that way. And then remember we talked about the sizes of each data type, right? Int is 4 bytes, right? So we're still going back to pointers, still going back to the whole thing of addresses. The way this thing works, right? Each position, it has its own addresses, because remember, every variable is stored at a specific address. So how does C++ know how to distinguish where the first box starts and ends? It looks at the size of the data type. This is 4 bytes. So if this is 0x, so I'm gonna make it in simple terms, right? I'm gonna use simple addresses. Don't worry about the 0x. That just tells C++ that this is a hexadecimal number. Our main focus is this 0, the last 0, this one over here. The 0x or the 0x is not important. That just tells C++ that this is a hexadecimal. We don't care about that. I want to explain to you the addresses. So C++, it sees, oh, this box starts from exactly there, right? Starts from there, position 0. This is 4 bytes. So that means I need to move 4 bytes, right? So I need to move 4 times. Therefore, this box, that's how it knows where one box starts and where one box ends. So this will now end somewhere here. But then this will now end at position 4, right? Because 0 plus 4 is 4, because each integer is 4 bytes. Then it knows, oh, so this stops here, right? But then, okay, like this, sort of like that. Yeah, let me put it this way. Hey, this is a proper diagram. I'm explaining to you arrays properly this year. I've never explained it in this way. At least now I can draw diagrams. So it counts how many bytes. So this is how it knows when to stop, where it starts and where it ends. But then you don't have to worry about this distance from 0 to 4. How does it know 4 bytes? You just put in a position, but just know it uses the addresses to know when to stop, right? Because do you know do you know why I'm doing this? Why I'm saying 0 to 4? Why I'm using these addresses? Because the computer, right, it is something that we call a main memory, right, which is where the variables and everything is stored when you're coding. It's stored inside the part that we call main memory. And the main memory has shelves or drawers, and each drawer is basically 1 byte each. So if I want to store remember one integer we said is 4 bytes. To represent one integer, I'll need 4 of these things, because each of these things is 1 byte. 1 times 4 is 4. So therefore, I'm going to need 4 of these. That's why it's important for you to know the starting and the ending address. Because if I have more than 4, the computer is a lot more. So imagine this is your RAM, right? Your main memory, where the variables are stored. You see that there's many drawers. How will C++ know where does one integer start and where does the other integer end? It uses addresses. Then it starts from 0. Now you start to understand why indexes actually start from 0. Because when it calculates the addresses, it needs to start from 0, then add 4, so that it knows that's the stopping point at 4. Then from 4 going upwards is the next variable. So that's one of the main reasons we have to start from 0. We can actually use this method, this property of heading to move into the arrays without putting positions or indexes. I'll show you how. That's why it's very important to really understand how things look inside the computer. So you have multiple of these boxes, right? So these 4 boxes, so C++ will now split them apart. It'll be like, oh, so this first 4, these ones that represent one integer. Then this other 4 represents the second integer. Then the other 4 represents the third integer. Then so forth and so forth and so forth. But just know they are placed one after the other. That's why C++ needs to know the starting address and the stopping address. That's why that's very important for C++ to know. Or else it's going to mix them up. And it's going to lose track and don't know where one variable starts, where the other one ends. Then it's going to have errors. Because what if it continues to read beyond the stopping point? So that's why I'm showing this example here. That's why that's why I started from 0 to 4 to show you that integers are 4 bytes. So when it calculates the address, it's going to add by 4, add 4 again. So this one would now stop at 0x8, because 4 plus 4 is 8. Then this will now be 0x12, because 8 plus 4 is 12. This is basically how it looks in the computer for any programming language, even Visual Basic, even informatics. But those languages are easier because you don't have to worry about pointers. They are managed for you by some languages like Visual Basic. In C++, well, you manage everything yourself. So this is how it would look, right? You'd have a starting and a stopping address. That stopping address, to be honest, yeah, to be honest, I think this diagram is not quite accurate, but it's fine. It's okay. From 0 to, because we need to have, why do I say so? Because we need to have some value here, right? Some address here, so that we know this is the first box, stops here. Then this one, it means the second one starts there. Then the second one stops here. Then we have another one, another starting point. I wanted to do that, but that's gonna take too much time. But just picture it in this way. Picturing it in this way is very sufficient. It's enough. You don't have to worry about it. So now how do we declare the arrays? How do you tell C++ that I want it to create an array? Basically, multiple boxes or multiple variables under one name. How do I tell C++? It's simple. So now we have, we're doing arrays. So how do you tell C++? You tell C++ by putting the data type first. So let's say int, followed by the array name. So I'm going to call it values in plural because there's multiple values. Then you put in square brackets. Then you specify how many numbers are there here. You put in a size there, an integer. And then semicolon. But then the C++ doesn't initialize so basically there's no, it's not the values at each position, they're not initialized. Excuse me. The values at each position are not initialized. So you would have to tell C++, go to this position, give it this value. So this is how you declare. So let me declare it. So int values, then I'm going to say there's 3 elements. There's 3 boxes because that's what my example says. There's 1, 2, 3. And don't worry about indexing. Here we're specifying how many elements. Don't put 2 because if you put 2, C++ is going to think, oh, you mean 2 boxes. So that's why I put 3. These numbers for positions is for us to go into the array at that specific position. That's only for that use. But when you specify the size, you have to put in a number there. So how do you initialize them? Before initialize, let me show you that these arrays, they're not initialized. So at position 0 and line. So what this means, I'm telling C++, go to my array, this one array, and then this square brackets, they mean go into a specific position. Then I put in the position number. So that means it's going to go into the first position, which is this first box. It goes inside that box and it sees what value is inside. Then it shows it to you. So I'm going to do this and build and run. You see that it's going to be a random value because arrays are not initialized. I didn't set it to 8, but all of a sudden there's 8. You see, it is the number 8. So that's something you need to really understand in C++. Variables and pointers and type aliases, all those things, they are not initialized. You must give them an initial value. So that means before you start calculating your totals or getting the values from the user, you must all set all of them to 0. So values at index 0 is 0. Then values at position 1 is equals to 0. Basically, I'm giving it initial values. And then values at position 2 is equals to 0. So what this means, I'm telling C++ again, go to this array code values, go to that position 0. And then remember what I talked about. At each position, it's a variable, it's a box. So that's why I am able to use this equal sign like a normal variable, because for all of this, you can imagine this represents just a variable like val. All of that represents one variable. So an array is a collection of multiple variables, and you can access one variable at a time by putting the position or the index. So this is how you'd get the value. This is how you'd set it. Like a normal variable. I'm sure you see a normal variable. You see how a normal variable works, right? But then the only difference is that you need to put in square brackets to always specify which specific variable are you referring to, because an array has multiple variables at different positions. So I hope that's very clear. So now since I initialize it to 0 here, when the output is going to be 0, because remember I compute a reads from top to bottom. It's going to read here, oh, you want an array with the random values because you didn't give it initial values. Then it's going to say, oh, position 0 is 0, position 1, the value is 0, position 2 is 0. Then here you're telling it, go to that box at position 0 and give me the value, which is 0, because I've set it to 0. So now when I build and run, my array is now initialized properly. So it has the value 0, right? So this is how arrays, how you'd work with arrays. I want to show you the pretty advanced way, but let me think about it. Before we do that, let's talk about another way to initialize an array, right? So here is another, I'm going to put a comment here, another way to initialize arrays. If you want to give a value, as the initial value, right? You could use a for loop, right? But we're not there yet at for loops, because you see this is a repetition over here. You can put it inside one for loop and then it repeats. Because what if I have 3 million values here? That means I'm gonna write these lines 3 million times. So you see, you can't be thinking like that. So for loops would be very useful there. But what if you don't really need for loops in this case, but you want to initialize multiple variables? How would you do that? Simple. You declare the array as normal. So let's say we have int marks. After the array name, you put in square brackets. Then you specify the size. How many elements or how many variables this one variable or this one array would store. Then I'm gonna specify, let's say 5. There's another way to initialize all 5 at the same time. You just say is equals to, then you put in curly braces, then semicolon there. Then at each position, you give it a value. So I'm going to say it's 0, 0, 0, 0, 0. That means I'm initializing for all 5. As you can see, there's 5 zeros. What this translates to, right? So let me put comments here so that to help you guys understand. So this will be a position 0, then position 1, position 2, position 3, position 4. So all of the positions are initialized to zeros. It's up to you. It doesn't have to be 0. It can be 10 or 35. It can be any number. That's fine. But I'm just going to use zeros because I just want to give them initial values to just demonstrate the example. And another thing you should be aware of, you can remember, you see here I've specified for all 5, right? What if I don't specify for all 5? Well, it is allowed. You can just omit this. But that means at position 4, it's a random value because I didn't initialize it. I only initialized at index 0, index 1, index 2, index 3. But index 4, I didn't initialize. So that means it's going to be some random value. So let's test it out to show you. So see out marks at index 4. Right, so I'm going to build and run. In this case, lucky enough, it is 0, but most of the time you're not gonna be lucky. It is 0. That's the random value that's stored as 0, lucky enough. But most of the time it's gonna be some random value. But do you see that C++ doesn't complain? It's allowed. You can initialize for fewer positions or fewer indexes than the maximum number of indexes you have. Or you can initialize for all of them. It's up to you, whatever approach you want to do. And since C++ knows that these variables or these values that you've passed aside, they refer to a specific position, you don't have to actually provide the size here. C++ can actually figure it out. So you can delete here, and C++ will know that it's actually 5 because it sees 5 numbers. So you see, my code runs, I build and run. It's successful, no issues, because I understand how C++ works. I understand the C++ syntax. So C++, you can create an array like this, and you don't specify the size here. But then just know the size is going to be whatever number of values you've put in this side. And just remember, each value is separated by a comma. Don't be those spiritual things and put colons like this. It's going to crash and it's not going to end well. That's why I give you guys homework so that you practice, because semester test 2, you're making a full game on your own from scratch. They'll give you a question paper and you have to plan and look at how you're going to create variables, functions, how you're going to name the functions on your own. There's no slides. You can't open slides. I'm sure usually what they do is when you're writing on that day, they delete all the slides from Eve. And you don't have access to internet to go on Google and use ChatGPT. So I would advise you for your practicals not to copy. Write them on your own because it's going to go down if you don't practice. So this is another way to create the array, right? Then what about, you might be asking yourself, Marase, you said arrays, they're like pointers. They store addresses and stuff. How come you're not using that? Good question. So let me show you that these things are, let me prove to you that they're actually pointers. Then we're going to end our session. So these things are actually pointers. So let me show you. So remember how pointers work. It's just the name of that pointer. Then you dereference or you point to. So remember what I talked about. I said that C++ needs to know the starting point of each. View this as the starting points, right? So that means this is not necessary. Yeah, this is not necessary. I can update my diagram. C++, it only needs one information to know the starting point, the starting address. That's all. Then C++ will know when to stop because it's going to look at the size. How many bytes is the data type? It's 4. So that means it's going to go here. 1, 2, 3, 4. So that means it stops here. It's actually going to stop here. Then it knows, oh, this is the first box. Then starting from here is the second box. So I'm going to use that understanding to my knowledge, right? I'm gonna use that to that understanding I'm gonna use that understanding to achieve things that I could easily achieve by indexing. I could make my life easy and just index. I would advise you do that, but I want to show you that arrays are actually pointers. I want to prove it to you. So you see, when I point like this, what happens is that C++, when you create a new array, C++, it's like C++ does this. It's like C++ creates the pointer for that array, right? And then it initializes it to the address of the first index at position 0. So it's like it gets the address at max position 0. So that's basically how it works. So it gets the name of the variable, the name of the array. It actually stores the starting address. That means basically you can get the first element by just dereferencing the name of the array. That's what I'm doing here. So I'm getting the value at position 0. That's basically what I'm doing there. And you see my code will work, no issues. So I'm gonna do this. So it is building and running. So there it is. There's the value over here. It works. Normal, perfect. Because I understand that arrays are pointers. That's why I explained pointers first before I got to arrays. Because if I had not explained pointers, you're gonna ask a question, what is this? But since you now understand pointers, you can somewhat figure it out. So I could actually output all 3 values. Let me do that, then we're gonna end our session. So this is value at index 0, right? Then I'm gonna repeat this 2 more times because I have 3 indexes or 3 positions. Oh no, max is 5. Yeah. So I'm gonna say 1, 2, 3, 4. 3, 4. Then how do I move to the next position? Because if I leave it like this, right, like this will still point. Okay, let's make it easy to pick it up so that you know that we are referring to that specific position. Let me change it to no more values. So 3, 4, 5, 6, 9, right? So that we know whether it's working or not. For now, it's not working because I am not updating my array. So this will only display for index 0 because I'm not updating the pointer because the name of the array is still pointing to the first position. I would have to add 4 to this number, to this address, add 4 to it in order to get the starting position for the next array, for the next variable. So I'm not doing that yet, so that you see that if you don't do that, you're still referring to the position 0. You see, I'm still referring at position 0. So I need to update. We call it, it's called in C++, it's called pointer arithmetic. Basically, doing maths with pointers. So how do we do that? You might think of since say I can add 4 like this, since it's for each integer is 4 bytes. But before, remember BODMAS brackets. I need to put in brackets because I want to add the 4 to max, not to this whole result. So that means I'd have to say brackets here, and then brackets there, and then output. I doubt this will work. Okay, it's no issues, but don't be putting magic numbers like that. But then you see, let me see something. Is it the right number? Yeah, it's not working. You see that it's pointing to the last position. This actually goes to the last position. Pointer arithmetic is very tricky. So don't add 4 like that because when you add 4, I don't know, C++ doesn't translate it well. You can just increment the pointer by 1. So you can just say max is equals to max plus 1. This plus 1, C++ is going to look at the data type of the array, right? It's int. So this means this is 1 times 4. So that's why here it pointed to the last index because it came here and then it said 4 times 4, which is 16, which is wrong. It's the wrong address. So that's why we're always going to add 1 to make it easy, right? So I updated max to 1. Then now I don't actually have to increment it here. You can increment it there, to be honest, that's fine. Remember, if you say this, right, this in C++ can be abbreviated in 2 ways. You can just say it's the same as max is plus equals 1, or you can say it's max plus plus like this. All of these 3 lines, they mean exactly the same thing. So what I'm going to do is I'm going to choose the neatest way to do this thing. So I'm just going to leave it as comments. You can check that out. So I'm going to update max, increment it by 1, which is basically 4 bytes. Then it's now going to move to position 1, right? Then I'm going to build and run. Okay. Seems like C++ is always acting up. So let me say it goes to max plus 1. Then let's see, still complaining. I don't know why it does that. It's fine. But this should have worked. It's fine. Let's do it this way. So let's edit here. Right. So you're gonna say max plus 1. Then you dereference, right? Which is the same as saying max plus plus, but now we're doing it there. Then now, instead of moving to position, so this allows us to move to position 1. In a way, right? So, okay, to make it simpler for you guys, you see these numbers over here. Think of it as the index, as the position. So I'm saying plus 1 because I want to go to index 1 or position 1. If I want to go to position 2, I have to say plus 2. If I want to go to position 3, I have to say plus 3. That's why when I said +4, it moved to index 4, to the last index. So you're gonna say +1 there, and then here you're gonna say +2, and then here you're gonna say +3, and then here you're gonna say +4. So you can imagine these are the indexes, right? But we're doing pointer arithmetic to it. So here is going to be build and run. Then you see all the numbers. There they are. That's the power of pointers. So if you really understand your pointers, you're gonna cruise nicely and you won't have any issues understanding anything. So this is arrays, just no arrays under the hood, they're also pointers. So I'll save this diagram now so that I can share it in the group so that you see how it looks. So this is about pointers, right? Or arrays. It's about arrays. So yeah, just know that the addresses that it always stores the starting address. So if you want to think about it mathematically, right? For you guys who know maths, remember I said it's times 4. Remember the name of the array always refers to the position 0 or the first address, which is imagine it's a 0, right? So if at position 0, I add 1, it's going to be OX1, right? Which is incorrect, right? It's going to be OX1. That's why I said it times it. It always times it by 4. So this will be actually times 4. You don't have to put the times 4. It puts it for you. So that means technically I'm saying max +4, which is basically me doing maths. I'm saying OX0 plus OX4, which just gives me OX4. So I have the new address for the other variable. Then I dereference or point to that address. So there's that pointer or dereference. In another way they use, they call it dereferencing. If I'm not mistaken, yeah. When you're accessing the value for a specific pointer, we call it dereferencing. So there's the maths, right? So you might ask, what about the 2? 4 times 2 is what? 8. So remember what I said, the array name always stores the beginning. So it's always going to be 0x, 0x0, then 0x, so 0x, so we have 2. So +2, right? This will just be 0x2, so +2. But then this 2, we need to times it by 4 again. We always times it by 4. The value we're timesing by, right, is the size of the data type in bytes. That's why I'm using 4. If you had a short is half the size of an int. So you'd have to actually multiply. It would multiply by 2 instead of 4. So 4 times 2 is what? 8. So this will be 8. Then this will be 0x8, which is just and then to dereference to point there, that means that I'm now referring to position 2, because you see position 3, 2, I mean, there it is here. So I'm now referring to the third element. So that's why it's like that. So I hope you guys really understood, and if you didn't follow, reading the textbook can also help. So yeah, I think this should be it for today's class. So let me stop sharing. Do you guys have any questions?